Hi, we are Appetite for Destruction, a group of parents who like to find solutions to common parenting problems using science. So far, we have worked a lot on reusable nappies to try to figure out why, after repeated use, some of them turn hard and crunchy, don't absorb quite as well as they used to, and have a persistent smell of ammonia, even after washing. So, we got a bunch of these problem nappies and tested them in a lab. Result? They are filled with bacteria. Maybe not that surprising given what nappies do, but it was very high. Why? What was the dirt clinging onto and how could we find out? That's when the lab we were working with had an idea. They put samples of the nappies in a blast furnace for 16 hours, burnt away the fabric and tested the ash that was left behind to see if we could find anything unusual in it. Ta-da! 3 out of 5 nappies contained a mineral called hydroxyl apatite. And this was in such high quantities that it accounted for roughly 20% of the whole weight of the nappy. "I've never seen or even heard of an ash value this high," said chemist Mark Smith. 1 to 2% would be normal, 5% would be high. So, with a combination of analytical chemistry, a partnership with scientists at Cardiff Catalysis Institute, and a grant from the Royal Society for Chemistry, we set off to solve this mystery. But what is hydroxyl apatite? With a bit of research, we discovered that hydroxyl apatite is what your bones and teeth are made of. Bacteria really like to stick to it, which is why we need to brush our teeth. And it is made of calcium and phosphate. But where do all these calcium and phosphate ions come from? Well, as a start, we know that hard water contains lots of calcium. But also, there is another substance which can contain lots of calcium and phosphate ions, and that is wee. So, we dug deeper into the mystery of hydroxyl apatite, spoke to more scientists, and found out that it forms mainly in alkaline conditions and dissolves in acidic conditions. Detergents are designed to make laundry slightly alkaline, because that's how they work best. And also, interestingly, children's wee starts off pH neutral, but becomes more alkaline when left in the nappy. So, could it be that an alkaline environment with lots of calcium and phosphate ions makes the conditions necessary for hydroxyl apatite to form and deposit on fabric? Time to test our hypothesis. Experiment 1. First, we asked the lab at Cardiff Catalysis Institute if they could create hydroxyl apatite build-up artificially to check what the ideal conditions for its formation are. We also asked them to analyse samples of our original smelly nappies on their scanning electron microscope to confirm if they could physically see the hydroxyl apatite build-up on the fibres. Experiment 2. We knew that hydroxyl apatite forms in alkaline conditions, so we used pH paper to test nappies at various moments during the nappy using cycle. Experiment 3. We sent to a lab some new smelly nappies which had been washed with different detergent dosages. We did this to see if the amount of detergent used made any difference to the build-up of hydroxyl apatite. Experiment 4. Some of our most heroic volunteers dipped nappies in their children's wee and left them to dry overnight, every day for a whole month. Apparently, it got very smelly. We did this to see whether hydroxyl apatite actually formed from wee, as we suspected. The results. The scientists at Cardiff confirmed our hypothesis that hydroxyl apatite forms at high calcium concentrations, as found in very hard water areas. They also sent back these images from the scanning electron microscope, which clearly show the mineral deposits lodged between fibres. Our pH tests confirmed that nappies have neutral pH when clean and become more alkaline the longer they are soaked in wee, i.e. overnight. Results from Shirley Technologies lab were not as conclusive. In fact, this time the experiment only resulted in 5% hydroxyl apatite deposits, against the 20% we found the year before. We couldn't see any pattern in what they found. In some nappies there was slightly more hydroxyl apatite in the wee zone, but in some nappies it was the other way around. It doesn't seem like wee causes hydroxyl apatite. The only samples in these tests with very high ash values were flannels, not nappies. And the ash from these was more calcium carbonate than hydroxyl apatite. Calcium carbonate is what limescale is made of, so not that surprising to find it in hard water areas. But none of the original nappies had calcium carbonate in. We don't really know what any of this means. Results of Experiment 4. The dipping experiment showed that no hydroxyl apatite formed in any of the tests, whether they were testing wee or water and detergent. We don't know what this means. Maybe 30 days wasn't long enough, and we would have needed to do the experiment for longer. Maybe it would work, but only with certain detergents, not the ones we tested. Or wee from some children. Phosphate levels in wee vary from one child to another and depending on diet, medical conditions and so on. What we do know is that our brave volunteers dealt with 30 days of festering, wee-soaked fabric, all for nothing. Although our resident scientist said that a negative result still tells you something, and that even for real scientists, a lot of the time your experiments don't work. So, this is science. What have we discovered? That doing science is like opening Russian dolls. Every question you answer leads to more and more questions. And, as well as having fun, we prove to the world that science is accessible to all, and that even a group of busy parents, driven by curiosity and determination, can contribute to scientific knowledge.